morning to all the people that watching this video. My name is Amir Reza, and today our group will be presenting about application of differentiation for maximum, minimum and inflection point. So for function y equal to fx, a stationary point is a point of the function graph where the gradient of the function is 0. If the gradient of the function change sign at the stationary point, then it is called a turning point, which can be local maximum or local minimum. That's for the definition of minimum, maximum and inflection point. So without further ado, I will go through for some example for you guys to understand better. So for the first example that I will show you is y equal to x cubed minus 27. So for the step is we must differentiate this equation for d over dx, and it will become like this. So it will become dy over dx equals to 3x square minus 27.
Assalamualaikum, my name is Muhammad Izzat bin Muhammad Ani Amin. I will talk about the next step. So for the next step, we must put the equal to 0. For the example, 3x square minus 27 equals 0. Then x square minus 9 equals 0 because it divided by 3. So bracket x plus 3 bracket x minus 3 equals 0. X can be 3 or negative 3.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adi bin Jamaludin. Today I want to continue the example 18 for step 3. So after step 1 and 2 done, the step 3 is find corresponding y value. So the first is y equals to x all of 3 minus 27x. The first substitute is x equals to 3. We work for that, so we can get the answer y equals to, in bracket, 3 power of 3 minus 27 in bracket 3. You can get the answer negative 54. So the second substitute is x equals to negative 3. We can get the answer y equals to, in bracket, negative 3 power of 3 minus 27 in bracket negative 3. So we get the answer 54. So the difference of these two substitutes is negative and positive.
My name is Muhammad Syamil bin Azmi. My matric number 14 DKA 20F1060, and I want to explain the next step. There is step 4 and step 5. Okay, let's go. Okay, as you can see in step 4, we all know that we got the stationary point is 3,54 and negative 3,54. That because we have done the previous step in step 1, step 2 and step 3, and in step 4 we got the stationary point. Okay, that's all. Thank you. As you can see in step 5, we have to use the second derivative formula, that is a d square y or dx square. We use this to find the stationary point. What type of stationary point is it? So the derivation formula is given is d square y per dx square equal to 6x. So when we use x equal to 3, the derivation is equal to 18, and the 18 is positive because we use it, the 3 is positive. And when we use the x equal to negative 3, the derivation is equal to negative 18 because we use the negative 3, and we got this x when we use the step 4. Okay, that's all for me, and thank you.
Final step is there is a minimum point at x3, y negative 54, and for the maximum point is negative 3 for x, y 54.
That's all is our presentation for today. I hope you guys really understand what are we presenting about today, and if you guys has any question, just comment down below.